All right, so let's try to prove the uh, trigonometric identities using Pythagoras theorem. Now, as we all know that we have three trigonometric identities. The first one is sine square theta plus cos square theta equals to 1. The second is sec square theta equals to 1 plus tan square theta. And the other one is cosec square theta equals to 1 plus cot square theta. So before we prove the identities, let's first of all write all the possible trigonometric ratios in a right angled triangle. So there can be only six possible ratios in a right angled triangle. As we all know that we always consider the opposite side to the angle of elevation as perpendicular. We always consider the adjacent side to the angle of elevation as base, and obviously the opposite side to the right angle is always the hypotenuse, which is the longest side of any right angled triangle. Now, there can only be six possible ratios. The first ratio can be of perpendicular to hypotenuse and vice versa, hypotenuse to perpendicular. The second possible ratio or the second pair of possible ratios can be base to hypotenuse and hypotenuse to base. And the third possible ratio or the pair of ratios can be perpendicular to base and vice versa, base to perpendicular. So let's write them down. So writing the first ratio as perpendicular to hypotenuse and its opposite as hypotenuse to perpendicular. Now, writing the second pair as base to hypotenuse and hypotenuse to base, and writing the third possible pair of the ratios of two sides of a right angle triangle as perpendicular to base and base to perpendicular. Now, we all know that we call this ratio as sine theta and its opposite ratio as cosec theta. In some books, you might see this written as CSC or theta. Now, moving on to the second ratio, we call this ratio as cos theta and its reciprocal as sec theta, and we call the ratio of perpendicular to base as tan theta and its opposite as cotangent or cot theta. Now, as we are done with writing all the six trigonometric ratios, let's move ahead to the proof. So, in order to prove these three trigonometrical identities, we will use the Pythagoras theorem. Now, Pythagorean theorem states that in any right angled triangle, the sums of squares of perpendicular and base are always equal to the square of hypotenuse. So we'll be using this theorem to prove the identities. So for now, let's consider this as equation number one. And as we all know that if we add or subtract or divide or multiply the same quantity on both sides of any equation, it does not change its value. So let's try to divide the equation number first by h square. We can get h square upon h square equals to p square upon h square plus b square upon h square. Now, this will be equal to 1. So we have 1 equals to P upon H square plus B upon H whole square. Now, as we all know that the ratio of perpendicular to hypotenuse is termed as sine theta, and the ratio of base to hypotenuse is termed as cos theta. So, substituting the values, we get 1 equals to sine theta square plus cos theta square. Now, reversing the equation, we will get sine square theta plus cos square theta equals to 1. And this is how we prove our first trigonometric identity. So we have already proven this. Now let's move ahead and try to prove the other two trigonometric identities using the Pythagoras